In example 1, it says, let 8, negative 6 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trigonometric functions of theta. So what we want to do is we want to graph that point. So let's get our axes drawn. And 8, negative 6, we've got 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6. So 8, negative 6 is the point just about right here. So here's our angle. And then what's happened is we've graphed our angle's here, but what we want to do is we want to look at that reference angle. So what we're going to do is draw our right triangle. So here's our right triangle right here. And this right here is the angle theta that we're going to be looking at. And then we can label our sides. So this is length 8. This side is length 6, but since it's in the negative direction, we say negative 6. Then what we need to do is we need to know what the hypotenuse is. So we're going to use the Pythagorean theorem to find that hypotenuse. So we can take 8 squared plus negative 6 squared equal to r squared. 8 squared is 64. Negative 6 squared is 36 equal to r squared. 64 plus 36 is 100 equal to r squared. So r is equal to 10. So we know this is 10 right here. And now that we have our triangle, we can go ahead and find our trig functions using SOHCAHTOA just like before. So let's go ahead and do that. So if we look for the sine of theta, the sine of theta is the opposite. So here's theta, it's the opposite over the hypotenuse. So negative 6 over 10. And then we always want to simplify our fractions. So negative 6 over 10 is the same thing as negative 3 over 5. Then we can find the cosine of theta. And the cosine of theta is going to be the adjacent, which is 8 over the hypotenuse. So we get 8 over 10. And we can simplify that to 4 over 5. And then if we find the tangent of theta, here's theta, is going to be the opposite over the adjacent. So negative 6 over 8. And simplifying that one, we get negative 3 over 4. Once you find these three, the other three are easier to find because you just need to take the reciprocals. So I'm going to move this over so we have a little bit of room. But now the sine of theta, the reciprocal, is the cosecant of theta. So the cosecant of theta is just going to be the reciprocal of the sine. So take the one that's simplified, this one here, and just flip it over. So we get negative 5 over 3. Secant is the reciprocal of cosine. So your secant of theta, if we take the cosine simplified answer and flip that over, we get 5 over 4. And the tangent and the cotangent are reciprocals. So cotangent of theta is going to be negative 4 over 3. Next, I'd like you to do the try this. So go ahead and pause it now and unpause it when you're ready to check your answer. If you did the try this correctly, the sine of theta, you should have originally negative 1 over the square root of 5, and then you should have rationalized it by multiplying by the square root of 5 over the square root of 5, giving you negative square root of 5 over 5. Cosine of theta, again, you should have started with negative 2 over the square root of 5, and then rationalizing it would give you an answer of negative 2 square root of 5 over 5. Tangent of theta is 1/2. And then do your reciprocals. So when we look at the cosecant of theta, now one thing to keep in mind, you don't want to flip this one because then that radical ends up in the denominator. Go back to the very original sign and flip that one and you just get negative square root of 5. Same thing with the secant. If we turn over the original one, take the reciprocal of this one instead of this one will give us a better answer for secant, which is negative square root of 5 over 2. And then the reciprocal of tangent for our cotangent would be positive 2. If you have any questions, let me know.